Good morning. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Advancing Hydrogen in Mobility. My name is Amanda and I'll be your host for today. Firstly, in keeping with our tradition, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their elders, past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Swinburne University of Technology. Swinburne University of Technology is focused on high-impact research, high-quality teaching, and active engagement with industry and the community. Swinburne is ranked in the top 350 universities in the world by the prestigious Academic Ranking of World Universities 2017. In engineering, Swinburne is ranked in the top 250 in the 218 Times Higher Education subject ranking. Swinburne has a long history of offering undergraduate and postgraduate qualifications. Its unique Bachelor of Engineering Honours Professional with guaranteed industry placement and Bachelor of Engineering Honours with optional placement have majors in architectural, biomedical, civil, construction, electrical and electronic, mechanical, product design, robotics and mechatronics, telecommunications and software. Today we will hear from 4 speakers, followed by a live audience Q&A session. I encourage you to send through questions to our speakers via the chat box on YouTube. I'd now like to welcome our moderator for today, Mr. Gordon Chakudoza. Gordon specialises in bringing together industry research, community and government to undertake transformative work in the development and adoption of new technologies. To date, Gordon has worked in a variety of roles and has held senior executive roles with private industry, the Victorian Government and Austrade. Please welcome Gordon Chakudoza.
Thank you very much, Amanda, for the introduction, and it's fantastic to be partnering with Engineers Australia on this webinar. It's really great to see a diverse range of participants from all over Australia and indeed internationally dialing in for today's event. Before I introduce our first speaker, I wanted just to spend some short moments to give a background about the Victorian Hydrogen Hub, which is part of Swinburne University. Next slide, please. I would also like to acknowledge the traditional owners of the land on which we are meeting and pay my respects to our traditional owners of past, present, and emerging. So you've heard from Amanda about Swinburne. I think we are a top university in Australia, very dedicated, strong focus on research and innovation. One of our recent initiatives is the Victorian Hydrogen Hub, which was funded by the Victorian government earlier this year. The Victorian Hydrogen Hub has 2 streams, an infrastructure stream and a research stream. The main goal of VH2, or the Victorian Hydrogen Hub, is really to work alongside industry on the implementation of hydrogen. In other words, helping industry to make hydrogen adoption at scale a reality. On the infrastructure side of things, we are building a refueler in partnership with our founding partner, CSIRO, and you're going to hear more about the refueler in a presentation later this morning. We've also partnered with Arena 2036, which is a research platform in Germany, where we're working together on storage tanks and pressure vessels. On the research side of things, we have assembled and continue to assemble a world-class research team that will work with industry on to address a number of research questions. Next slide, please. So you can see here our strategy, which is outlined on this page. But just to summarize there, you can see that a key sector focus for us is transportation and mobility. So we're delighted to be part of this webinar to give you some insights on how we're working with industry to advance hydrogen in mobility. Some of the other areas we're going to be working on is around skills, so identifying what skills might be needed for a future hydrogen economy. We're also going to be doing work around the acceptance of hydrogen, so working with local councils and state governments to bring the community along the journey of hydrogen. And through our industry readiness program, we'll be working with SMEs to educate them what hydrogen might mean for their own businesses and help them get ready for a hydrogen economy. Next slide, please. And through our PhDs, we'll be working with industry to look at how we can work with industry, particularly around those industries which are hard to abate. So you can see some of these industries which will be our PhD candidates will be involved in. So we'll be looking at things like decarbonization of ports, looking at hydrogen application in aviation, steel making, skills, and continuing to build our modeling strengths. So I hope that gives you a snapshot of the Victorian Hydrogen Hub. I would now like to introduce our first speaker today, who is Swinburne's Professor Hussein Dia. Professor Dia research is focused on disruptive mobility and harnessing digital innovations to unlock potential opportunities for low carbon mobility.
Cannot access it.
Professor Dia is a chartered professional engineer, amongst other qualifications, and is also served as a board member of ITS Australia. Please welcome Professor Dia.
Very good. Good morning, everyone. And it is my pleasure to be with you this morning. I think I see it now. Yes. Apologies for that. Good morning, everyone. It's my pleasure to be with you this morning to share some insights on the role of hydrogen in decarbonizing the transport sector. Emissions from the transport sector continue to present major challenges to countries around the world. Overall, as of 2018, transport accounted for around 20% of the global emissions. And while some progress has been made in some of the developed economies to reduce emissions from transport, there are some of the emerging economies are actually moving in the other direction and contributing more. So that remains another challenge. Around 75% of the transport emissions, as you can see in the slide, came from road vehicles, approximately 45% from road passenger vehicles, including cars, and around 29% from road freight. Aviation and shipping contributed equal amounts, almost around the 11% mark. And as you can see, these top three sectors are the ones that are probably most ripe for decarbonization. Good progress has been made with the road sector. And I think there are many challenges remaining with the shipping, aviation, and also road freight, where hydrogen can play a big role. So in terms of the local landscape, it is a similar story. The transport in Australia accounts for around 17% of all emissions, with passenger cars accounting for around half of those emissions. The situation is a bit further complicated in Australia in that the transport sector has been for a while one of the strongest factors in emissions growth. Basically, the emissions have increased nearly 60% since 1990, more than any other sector. And according to a number of studies, Australia's per capita emissions are 45% higher than the average OECD. So Australia lags behind. In this particular scorecard, it ranked 20 out of 25 countries for transport energy efficiency. So this was based, this particular scorecard looked at the national effort, looked at decarbonization of buildings, industry, and transportation. And as you can see, transport is one area where clearly a lot of work is needed. Unfortunately, over the past maybe 30 years, the decarbonization of transport was not given a high priority on the agendas of transport planners and decision makers who were basically dealing with much larger issues than rapid urbanization, crashes, congestion, and essentially there was a lot of focus on the need to meet people's need for travel using motorized transport. The good story, I suppose, is that over the last decade, things have started to swing, and there is more focus nowadays on giving, emissions and energy provision and consideration of climate change into the equation. So the typical response policies in the past have been to expand, so build out of congestion, build more infrastructure, give more priority to the movement of vehicles, give more priority to motorized transport. The new, more sustainable responses are more focused on managing the demand for travel, looking rather than just focusing on the movement of vehicles, looking at the movement of people and goods, having a consideration of the low emissions transport, more sharing, using pricing instruments, and so forth. In simple terms, we summarize the sustainable transport framework under the avoid, shift, share, and improve policies. So with the avoid, you're reducing the need for travel, which is something we have experienced over the past 2 years by working from home. So telecommuting is part of the equation. Other strategies is to shift from energy intensive to more environmentally friendly modes, to share the mobility resources, and improve the energy performance of the transport systems. So we've been doing some research on this and looking where to essentially target the research effort. We found that the avoid or reducing the need for travel strategies could actually pay the most dividends. So this is examples, for example, travel demand management, telecommuting, virtual mobility programs. The shift strategies, shifting from private cars to public transport to micromobility, e-scooters, e-bikes, walking, cycling, and so forth. Then sharing of resources. We've seen that over the past 10 years with the likes of Ubers and car sharing programs, ride hailing, and so forth. And the final one where technologies and alternative fuels come in as well is to look at the improved strategies. And this is where the energy innovations come in. As you can see there, I haven't assumed that we're going to reach full reduction from 100% business as usual today over the next 10, 20, 30 years. It is possible that we won't get exactly to zero, but it will be, the intention is to get as close as possible to that. So this brings in the hydrogen equation as well. So hydrogen is expected to play a big role in decarbonizing a number of industrial and transport sectors. As you can see here, this is a big shopping list of possible use cases where hydrogen can be beneficial. And as you can see on the right, aviation and shipping particularly, and land transport are part of the mix. So hydrogen could play a very big role in some of these use cases, and it could play a minor role in other applications. I think particularly as we look at decarbonization of the transport sector, three of the biggest challenges remain shipping, aviation, and long-haul freight, where we still need more research clearly. This diagram essentially shows, as you climb up this ladder, the use cases become much more challenging to decarbonize. but at the same time, they open opportunities for hydrogen to have a role, but hydrogen would need to compete with other alternative or other new technologies or solutions that are being proposed. It needs to compete based on cost, in transport based on range, which it actually has the upper hand compared to other solutions, safety, public acceptance, and so forth. And there is already some good research overseas on the potential of hydrogen aircrafts, and also in Norway, we're starting to see from high seas some prototypes of vehicles or ships, for shipping. So when we talk about some of the current research in order to essentially establish which use cases could have best impact or most impact, one way to address this, and we're doing this through a current research project, is to look at life cycle analysis or assessment. So this particular project is looking at using the GREET model, which is a life cycle assessment model developed by the Argonne National Laboratory in the US. And to our knowledge, it hasn't been calibrated for Australian conditions yet. It has been used widely overseas. So this project would look at using this particular model to examine the prospects for decarbonizing the freight sector in particular, using renewable energy. Before I leave, I would like to maybe leave you with a thought. Even if we make each and every one of these vehicles hydrogen or electric vehicles, we are not going to be able to solve a lot of the challenges I mentioned before. One of the difficulties we have, for example, is that in Australia, if you stand on the side of the road and look how many people are in a car, it's on average 1.2 to 1.4. So around 80% of the car journeys to work have no passengers. So we need a holistic approach. We are all for alternative fuel vehicles, but they need to be part of a holistic solution where we also look at the sharing of resources. And also, because we are going to be relying on renewable energy, to also select applications where there will be the best return on investment, if you like, and also the best return on the conservation of the resources. Thank you for your time. This concludes my presentation.
Thank you very much, Professor Dia. That was a fantastic overview of the potential applications in hydrogen in a number of transport areas. Just a reminder that we will have a Q&A session at the end of the speaking panel, so I'll move straight to our next speaker. Our next speaker is a joint presentation by Dr. Patrick Hartley and Mr. Sean Blythe. Dr. Hartley is the lead of CSIRO Hydrogen Mission. He has established the CSIRO's Hydrogen Energy Systems Future Science Platform and co-led the formulation of CSIRO's National Hydrogen Roadmap. He has also co-authored more than 90 peer-reviewed publications. Mr. Sean Blythe is the founder, director, and CEO of ENGV. He has over 20 years experience in the gaseous fuels and renewable infrastructure industry, with a focus on technology deployment and implementation. Please welcome Dr. Patrick Hartley.
Thanks, Gordon, and good morning, everybody. It's a great pleasure to be with you today to talk about our involvement in the VH2 program, which of course we're very excited about. And before I get started, I'd just like to add my acknowledgement of the traditional owners of the lands on which we're meeting, to the others that we've heard previously, which in my case is the Boon Wurrung people of the Kulin Nations here in Victoria, and I acknowledge their traditional owners, past and present. It's quite an opportune moment actually for me to be talking to you from the Kulin Nations lands, because I'm actually not at work in the CSIRO site. I'm actually visiting another very important piece of hydrogen infrastructure here in Victoria, which is the hydrogen liquefaction plant in Hastings in Victoria, which will be in January I think it's January or early next year, will be the site of the arrival of the first hydrogen carrier ship, liquid hydrogen carrier ship, to Australia, and that's all part of the Victorian Hydrogen Energy Supply Chain project. So behind me, about 50 meters, the liquefier is running and producing around about 250 kilos of liquid hydrogen a day. So, so again, an important piece of infrastructure relating to hydrogen. So before I actually launch into the talk as well, I just thought we'd run a short video which describes the hydrogen industry mission in CSIRO.
Tackling climate change means we have to work hard to reduce our greenhouse gas emissions. We've made huge strides in the use of renewables to produce electricity, but some sectors are harder to decarbonise. This is where hydrogen comes in. Hydrogen can be used in a variety of industrial and domestic applications. Importantly, whenever it's used, it produces no greenhouse gas emissions. Australia is perfectly positioned to establish hydrogen export supply chains, which presents real opportunities. It's estimated that a clean Australian hydrogen industry could create 8,000 new jobs, generate $11 billion in GDP a year, and reduce greenhouse gas emissions. So, with a strong global market pull, technological readiness, and an appetite for the potential of hydrogen, we're at a critical stage. Challenges remain, however. Hydrogen is still expensive to produce relative to current fuels, and using it requires new technology and infrastructure. CSIRO's Hydrogen Industry Mission has been created to help focus research and development on solving these challenges to accelerate the development of Australia's domestic and export hydrogen industries. With our partners, we're supporting hydrogen knowledge sharing, informing best practice through feasibility studies, demonstrating hydrogen technologies and infrastructure, and delivering practical research, which helps de-risk hydrogen industry investments. The mission's success depends on strong collaboration across industry, research, and government. For more information on how we're looking to collaborate, visit our website.
So thanks for that, and yeah, I'll jump into the presentation now and just I guess give a little bit more information about the mission and what we're doing. So as you can see from the video, really the mission has really been established to get behind the development of Australia's hydrogen industry in a number of ways that were described on the video there. The 4 pillars of the Hydrogen Knowledge Centre, the feasibility and strategy studies, demonstration projects, and enabling science and technology. And of course, some of our partners, including Swinburne, listed along the bottom of the screen there. What we're here talking about today is, of course, demonstration projects. Right, and you know, the phase, the sort of stage that the industry is at the moment, really, is demonstrating hydrogen technologies across many of those different value chains that we know we heard about previously. And as we look at the context for the Refueler project, we go back to the work that we did back in 2018, and since many other people have come to the same sorts of conclusions, which is in some ways gratifying, which is that mobility is a key near-term opportunity for the hydrogen industry development or hydrogen use in decarbonising energy systems. The reason for that is kind of summarised by this graph from the roadmap, which is that passenger vehicles and vehicles in general, the incumbent fuel there is obviously petrol and diesel, which is a relatively expensive fuel, and that means that as hydrogen costs come down, they start to approach the ability to displace those fossil fuels in a cost-efficient manner. So mobility is a near-term application. As we move to the right of this graph, of course, and costs come down further, that's where hydrogen can play a role in many other industrial sectors. So recognizing that, I guess back in 2018 was really the genesis of the project that we're here talking about today. You know, really we felt there was an opportunity for CSIRO to leverage our infrastructure, our skills. We've been working with hydrogen for many years from a research perspective, and our site in Clayton, where I'm normally based when I'm not down here looking at hydrogen liquefaction plants, is actually a pretty good location for installing refueling infrastructure, we felt. We're very close to major arterial roads heading into the Melbourne CBD, the Monash Freeway and the Princes Highway. We're to the southeast of the city, just about 20 minutes to the southeast. The surroundings of our site We have Monash University to our south, and around us to the north in particular is a kind of a light industry area. So it's actually quite a good spot for essentially allowing people to try hydrogen technologies and hydrogen vehicles. As I mentioned, we've got existing infrastructure, things like our Centre for Hybrid Energy Systems, which already has hydrogen technology under development as a part of it, are all on that site. So we're well equipped with the skills, the infrastructure, and of course, most importantly, the safety systems to install things like hydrogen refueling systems. And so the project concept really was that we wanted to couple an end-use demonstration, a commercial demonstration effectively of hydrogen refueling with research and development. And so you can see here how that works. We have a building which is very much a part of the Victorian Hydrogen Hub, which we're fitting out with hydrogen equipment and hydrogen infrastructure, where we will be demonstrating hydrogen production, hydrogen storage, and hydrogen utilization technologies. And really stitching those together with that end-use demonstration of a real commercial application in vehicle refueling. I'm glad to say we haven't got our refueler yet, and we'll come to that in a moment. But we already have a hydrogen vehicle in our fleet, which we've leased from Toyota. So that's actually sitting just outside the window here, and yeah, very nice to drive, I must say. You can also see here we have we have two sites basically in the Melbourne area there, CSIRO Clayton, which I've been talking about, but our site down in Geelong as well. It's actually a really suitable distance for travelling that hydrogen car back and forth. And importantly, the current refueling system that's here in Melbourne at Toyota's plant in Altona is sort of midway between those sites. So it's a really good location for trialling hydrogen vehicles. I guess overall, the project was given a real shot in the arm in February this year with the announcement of the Victorian Hydrogen Hub and the partnership with Swinburne. So very much a collaboration with Swinburne University. The refueler, as I mentioned, will be located at our site in Clayton, and we'll be working with Swinburne and many other partners to install technology development and demonstration projects within the building. And obviously the funding from the Victorian State Government was a very important part of that, which came to Swinburne and helps us leverage CSIRO's investment in the refueling system. And we'll hear a little bit from Sean Blythe in a moment about the development of the system. But I'll just give you a quick overview of the project timeline, where we've come from, where we're going to. So we really started working up the concept through 2019, and that was very much establishing the idea, the concept, securing support from CSIRO for around about half the costs of the refueling system. We worked through site assessment surveys and an industry expression of interests with GHD, a large consulting company. And we're ready to go essentially towards the end of 2020 with our tender, so that was successfully launched. The tender was delivered. We selected through that tender process the NGV, which is where Sean comes into the picture as the preferred procurer and installer of the hydrogen the hydrogen refueling system at the site. And as you can see there, the announcement in February 2021 of the Victorian Hydrogen Hub was pivotal in really getting us over the line to install the infrastructure. So thanks to everybody who's been involved. Really, it's been quite a long journey. And so I think with that, I'll actually hand over to Sean Blythe at ENGV, who can tell us a bit more about the details, the technical details of the refueling system, which is currently under construction. Over to you, Sean.
Thank you. Okay, thank you very much. Firstly, thanks to Engineers Australia and Swinburne University for arranging this. Really appreciate it, and we're very proud to be working with CSIRO with the opportunity to deploy this hydrogen refueling station at their facility. Just a little bit about NGV and who we are. Like many commercial businesses in Australia and around the world, we've recognised the need to move to a sustainability platform, and we've been working on this quite explicitly for the last 5 years. We've developed what we believe is a very strong global partnerships with leading technology partners who we believe are at least as good as the best, if not the best in the world. Our job is to bring this to Australia and integrate. Hydrogen, renewable green hydrogen is a key platform for us as a business. Too many times. So just a little bit about the technology before we get into the site. Hydrogen's not new, and hydrogen compression is not new. When it comes to compression, we work with PDC out of the USA. They've supplied over 4,500 diaphragm compressors and over 500 compressors since 1977 around the world. They're a very recognised and experienced partner, and we're very proud to be working with them. And the solution we're bringing to this application is very much based on proven technology, deployment in Australia in the Australian context. Not moving. Oops, sorry, I went too far. So I think it's really important when we talk about hydrogen refueling, in so much we refer back to where the industry has come from and what technology is actually being deployed. A primary component, assuming you've got the electrolysis being produced safely and efficiently, is the compression. The compression bit, in all honesty, is not the difficult bit. The more challenging part is the integration of the discrete parts of the solution into a complete solution that gives a great refueling experience that's safe and reliable. And that's one of the issues that's been identified by PDC and why they developed what we're actually deploying at CSIRO, which is we call a simple fuel fast, which is an all-in-one refueler, which is very similar to the middle picture there and the like. Now, just for your reference, we were also fortunate enough to be selected by ActuAGL to build the first public refueling station in Australia, and that was commissioned in February, March this year during COVID time. So it was rather difficult and challenging, but we have achieved that. That's refueling 20 Hyundai Nexos at the moment in Canberra, and that's operating quite well with a few little issues that we're progressing and improving like we always do on the first units in any country. One of the opportunities and challenges for the CSIRO project was the location, a great in principle location, but is a brownfield site. And I think that's created an opportunity for us to learn and to build the learnings for the industry. Certainly, it's nice to have new concrete and new sites, but often this infrastructure has to fit within existing sites and locations and environs. So one of the strengths of a modular, small, scalable solution is it enables very small setbacks and the like. And one of the reasons why we're very keen to deploy these units around Australia and very excited to be growing that market. From a technical perspective, what's different from a simple fuel to standard applications? To our understanding, this is the only such unit that's being developed around the world. There's approximately 10, 11, I think, being deployed now. We will be deploying this. It's in build now in the USA in 2022 in Melbourne, as been stated. The simple fuel is very unique in so much that it actually has an electrolyzer inside it, which is actually a plug power 20 kilogram per day production. So we're producing hydrogen on site in a small PEM electrolyzer. We're compressing it up. We're on storage that will be adjacent to the actual compressor and electrolyzer unit. The hydrogen then flows back in under pressure into the simple fuel where it's pre-cooled and then fuels the vehicle. It's effectively a fully approved appliance. PDC IBES work with Intertech to have the unit certified to the appropriate standards. From an Australian perspective, the appropriate standards are obviously we use ISO 19880 for the gaseous hydrogen refueling, as well as AS 679 for hazardous electrical and the like, and IECEX components. So it's very important from our lessons in being involved in engineering projects and innovation projects around Australia. One of the key issues is actually how it integrates and how it operates in an Australian context. We very much do not take a helicopter view. We go very early, very hard to identify the opportunities and threats around the operability of the units. So this is a proven unit. We've already got one in Australia. Is it not going forward? Sorry, it's just frozen here. Okay, sorry. Okay, great. So thank you for that. So this slide actually just talks about why the simple fuel. We're not suggesting that the simple fuel is the ultimate answer for large-scale domestic car refueling. What we see the simple fuel as is very much a pathway to socialisation, testing fleets, and enable sites for up to maybe 20 cars a day, 20 cars a week, 5 to 6 cars a day, potentially to refuel. Obviously, the amount of gas being flowed is not too high. So we need to be very careful that we're not over-capitalising, and we want to provide a deployable solution that ultimately can be scaled up, relocated and moved if required, but also provides a robust refueling experience. So as compared to a traditional hydrogen refueling station, which we also supply, it's very critical in our view to get a base of refueling opportunities for customers to experience and to demystify this thing called hydrogen mobility. So Simple Fuel and IVAS have recognised that, and they've developed this unit along that basis. One of the critical issues is actually it's not just about building it; it's about operating it and making sure when cars come to refuel that they get a full and reasonable state of charge. It's really important, I think, from an engineering perspective, to appreciate that this is not a liquid fuel; it's a gaseous fuel, and how you refuel with gas as opposed to liquid is very much around the peak refueling requirements within 1 hour, for example. So it takes a lot more time to recharge the backup storage. You don't have a large liquid base there that you can just ram into vehicles. So the early engineering and the design, the interconnections are very critical. If you don't do that at the beginning, you will have a failed project. The station may work, but it might disappoint. At this point in the industry's evolution, we're very keen to complete modelling and ensure that both the customers, and when I say the customers, I don't say CSIRO here, I mean the people using the vehicles, are happy with the response time, the refueling experience. And that's one of the things that IVAS PDC pay a lot of attention to and have modelled up, which such models is here, and 24/7 call out if there is a problem as the industry is developing. So that's an example of one of the first units that has been deployed. That's actually in Boston. That actually fills that car in about 20 minutes. It's called an ambient fill. It's not a fast fill unit, but certainly it's a very low cost option and does enable a vehicle to get 2 to 3 kilograms within 20 minutes. Rooftop solar, that's a place called Greentown Labs, which is an incubator set up that has about 30 different innovation companies working together. That's actually where IVAS is based. The beauty of this solution is the ability of it to be located in very tight areas due to the hazardous area classifications that they've been able to achieve. This is the 7th installation, which is actually a very similar installation, but with the Department of Energy for those guys to refuel their fleets in the US. And now we're on to the CSIRO site. So this is actually our modelling, and apologies for the Texan hat there. But as you can see, we do 3D modelling, hazardous area classifications, and all the like. So typically, the way this solution works, just to talk it through for you guys, is that renewable power will come in to the simple fuel. Water will come along here via this deionizer here. Water flows into the electrolyzer contained within the simple fuel. It goes through the electrolyzer to produce hydrogen and oxygen. The small amount of oxygen is vented to a safe area. The hydrogen is compressed and goes through this easement into this cascaded storage facility here. The hydrogen, when a car comes up, it talks through this communication at the hose level from the Mirai in this case. It does a quick safety check to make sure everything is doing what it should be doing. It then allows gas to flow and is metered from the simple fuel into the Nexo or Mirai, depending on what vehicle is being used. That refueling protocol is to the SAE protocol, which is one of our important criteria that we have to succeed and be certified to. That's a bit of a boring site, but it just shows a top-down view. Once you've got your P&ID, this is an engineering discussion, we would then do a detailed hazardous area classification, risk assessments, and the whole process to verify that what we're proposing is suitable and safe to be deployed. All of that work is being done and will be completed prior to installation. But certainly it's already been done from a desktop and preliminary design. So that's a side view. Part of this project is absolutely, as Patrick mentioned, demonstration, education, and building an industry for Australia. And what we're discovering here, in each project we do, we're on to our 12th hydrogen project in Australia now, between compression, storage, and electrolysis. So there's a lot of talk about hydrogen, but I would say certainly that the projects are happening. And as I said, we're very excited to be working on this project because it ties in storage, compression, and risk assessments and processes. So we're getting better every time, and we're very pleased to be sharing this under such scenarios like this and with CSIRO. So as I said before, it's not a liquid fuel, it's a gaseous fuel. So one of the things we need to be very certain about is that the scope is very well understood, the requirements and the standards. So we've been through that. It takes quite some time, but we've been very closely with our OEM partners from overseas, with CSIRO, with the operators on site, with the engineers supporting CSIRO, GHD, and our internal engineering team. So it's a very clear program, a very specific program, and a very verifiable program. So that's just an example of the sort of process we would go through and what we would check off. This is my last slide. So it is about lessons. So the first unit is already in Australia. It will be commissioned in February. It will be used for refueling forklifts. So we're very excited about that. So in terms of electrical conformity and approvals, that's well and truly already completed. It is site specific, but from a generic perspective, we've got those approvals and certifications in place as well. So that's really exciting and certainly de-risks this project. In terms of the right-hand picture there, I thought this was a very worthwhile one talking about. Everyone talks about the SAE refueling protocol that we must comply with, but no one actually wants you to test the stations on your own vehicles or the first vehicles. It was something we learned after we started the actual AGL hydrogen refueling station. So we had to invest quite a bit of money in developing a hydrogen station test rig. There is one of these or two of these in the US that I think cost $500,000 to develop, but with DOE funding, we had to very quickly develop our own hydrogen refueling station test rig, which is that picture down the bottom. And what that does, that's in effect mimics the refueling system on a vehicle. And we data log, and we're measuring temperature, pressure in 1,000 bar rated cylinders inside that container. So it's just a lesson about being first. When you're first, there's often things that are missed. And one of the things we didn't identify was the inability to have a vehicle to actually confirm that the station complied and refueled to that process. Even though we had it certified in the US before it came, everyone wants to see what actually happens on site. So there's one learning. We've now invested in that, and that's available for other sites to also be used to verify the flows and temperatures and pressures to ensure compliance. So certainly, we're not saying we've got all the answers. We're very excited to be partnering with CSIRO, and we're really very happy to be sharing our information as we go forward. So thank you for the opportunity to speak.
Thank you very much, Sean. That was a great presentation. Some terrific insights on the technologies around the refueler. And thanks to Patrick as well for giving us an overview of the CSIRO's hydrogen mission. Moving on to our next speaker, I would like to welcome Ms. Claire Johnson. Claire is the Business Development Manager at Hyzon Motors, a pure-play hydrogen mobility company with an exclusive focus on the commercial vehicle market. Previously, Claire was a inaugural CEO of the Australian Hydrogen Council and is passionate advocate for the hydrogen and the role it can play in Australia's transport sector. Please welcome Claire.
Thank you so much, Gordon. Apologies for the delay. It's wonderful to be with you all today at what is really a perfect time to be talking about hydrogen in mobility. At this point in time, we have the opportunity to talk about real projects, real products, and real investment. So we really are moving beyond that signalling intentions phase, which we've seen over recent years, to moving into project implementation. And Australia is really on the fast track to become a hydrogen leader in developing hydrogen economy. In fact, just this week, the International Energy Agency identified Australia, along with 3 other countries, including Spain, Chile, and China, as being the 4 major hydrogen leaders worldwide. And together, these 4 countries will contribute about 85% of green hydrogen production in the year 2026. So it's a fantastic time for hydrogen. It's an exciting time for hydrogen mobility. Hyzon, the company I work for, has a sole focus on hydrogen mobility in the commercial vehicle segment. We have a number of projects in Australia. Commercial mobility is probably one of the most leading subsegments of the hydrogen value chain that will reach competitiveness first, and we see enormous opportunity to roll out our vehicles Australia-wide. Next slide. Thank you. So we have a really high focus on developing the Australian marketplace for hydrogen commercial mobility. We are a US headquartered company. We manufacture our trucks in the Netherlands and in China, but we see that Australia really is going to play a strong leadership role as we start to roll out our prime movers, rigids, coaches and city buses Australia-wide. Now, what's driving this? So what we're seeing is an enormous number of fleet operators looking at how they can decarbonise their fleets. They have decarbonisation targets that they need to meet. They've addressed the light vehicle segment already, but now they're looking at their heavier vehicles. And increasingly, they're turning to hydrogen to do that. And some of the key advantages of hydrogen in the heavy vehicle segment, of course, include things such as fast refuelling, additional range, and also additional payloads. So Australia really will play a strong leadership position in rolling out hydrogen commercial vehicles, and this is also being recognised by governments. So fleet operators that want to decarbonise are also tapping into funds available by both federal and state governments in Australia, which currently amount to over about $2 billion. And many of those funds are being directed towards hydrogen hubs. And in the environment where we're not yet exporting hydrogen at scale, industry players are looking at what domestic applications can they start pursuing to start building their capability in hydrogen now. And mobility is really one of the best places to start, with real product available today to arrive in Australia from early next year. Next slide, thank you. So Hyzon is a relatively new company. We launched the company in 2021, but we have been producing fuel cell technology for almost 20 years. So the company has been developing fuel cells since 2003, predominantly for stationary power applications. But through Hyzon, we're deploying this technology into mobility for the first time. And we've deployed around 500 vehicles worldwide to date. And we anticipate production volumes of about 1,000 vehicles in 2022. So on this slide, you can see our existing and product lineup in development. So at this point in time, we develop hydrogen fuel cell trucks up to 70 tonnes in gross combined mass. But we also produce more bespoke applications in the rigid segment. So applications such as garbage trucks, which are perfect for hydrogen given the significant power draw, and also concrete mixers. We're also, in the truck space, we're also moving towards launching our next generation fuel cell, which is a 370 kilowatt, 500 horsepower fuel cell system, which will be one of the most power dense fuel cell systems worldwide. And we'll be utilising that technology in road trains. So we'll be delivering vehicles with a GCM up to 140 tonne to Australian customers from next year, which I'll touch on one of those projects shortly. We're also in the bus space as well. So we're bringing coaches into the Australian market from next year also. And we're also working in partnership with bus operators for city bus operations around Australia too. So at this point in time, we manufacture these vehicles overseas, but we're looking at opportunities for local manufacture as well, just because of the demand pipeline which we're seeing from operators across Australia, and also because of some bespoke Australian unique requirements that we think warrant developing local manufacturing capability here. Next slide, please. So as I mentioned, from early next year, we will start bringing our vehicles into the Australian market. In fact, we have introduced our first coach to Australia just a couple of months ago. That vehicle is currently undergoing testing in the country, and we'll be showcasing that vehicle as well. But we really see that from 2022 onwards, we'll start delivering our vehicles in volume to Australia and worldwide. As I mentioned, we're seeing enormous appetite from fleet operators really trying to understand their fleet transition pathways and the technologies that are available to them. So they're increasingly turning to our company as one of the only suppliers of hydrogen heavy vehicles in the market today. So you can expect to see a significant amount of activity from next year forward. Next slide. So I just want to touch on two of our key projects that we're currently progressing with industry partners. And the first one of these, which receives a significant amount of attention, is our partnership with Fortescue. So Hyzon will be supplying 10 hydrogen fuel cell coaches to FMG in the early part of next year. These coaches will be deployed at their Christmas Creek iron ore mine, and they'll be used to transport mining workers from their residential facilities to the mining site. Now, as you can imagine, the environment, the conditions that we're deploying these vehicles in is extreme. It's hot, it's dusty, and so we have essentially developed a bespoke system that will manage the dust and heat conditions that we'll face. Obviously, dust is a huge issue with fuel cells, so we've undertaken local development around dust filtration systems and tested these at the mining site itself to ensure that our vehicles perform at the standards required for FMG. So it really demonstrates that fuel cells can operate in some of the most harshest conditions in the world. And we look forward to, once that project has been rolled out, to working with other operators of coaches across Australia and seeing more of these vehicles in the coming years. Next slide. So the second project, which has recently been announced, is our partnership with Arc Energy. Now, Arc Energy is a subsidiary of Korea Zinc, which is the largest zinc miner in the world. Arc Energy's remit is to decarbonise Korea Zinc's operations. They're starting with their Townsville operation. We'll be supplying them with a fleet of our heavy duty, ultra heavy duty road trains. Now, these road trains will feature our next generation fuel cell and will allow us to provide them with vehicles that will have a gross combined mass of up to 140 tonne. So what this means is they'll see some of the biggest hydrogen fuel cell vehicles deployed worldwide, and really will be unprecedented in the ultra heavy duty fuel cell segment. These vehicles will be operated on a short route, about 30 kilometres in length. So fortunately, we don't need an extensive range, which means we can minimise the amount of hydrogen tanks that we deploy on these vehicles. But it's really important that our fuel cell is obviously up to carrying some really significant loads that, as I said, are really quite unprecedented in this space. So we'll be delivering those 5 vehicles to Arc Energy in the second half of 2022, and obviously an enormous amount of attention on that project as well. Once we demonstrate the feasibility of that project with Arc Energy, we anticipate deploying these vehicles with miners across Australia. We're seeing significant interest from a lot of major miners and also internationally as well. Next slide. So one of the key challenges, of course, which we must touch on, is building out the infrastructure. So at the moment, Australia has a very limited amount of hydrogen refuelling infrastructure nationwide. We currently have about 3 stations that are operational. Obviously, we need many, many more to roll out our vehicles and other OEM vehicles in volume to our country. So we're working in partnership with organisations across the hydrogen value chain to start building out that network infrastructure so we can start deploying our vehicles in volume. So next slide. So to do this, essentially most of the customers we're dealing with to date operate back to base models. They're all generating their own hydrogen. They have a single refueling point with vehicles that return to their facility each day. So that really means that we can work with them in developing stations that are high utilisation, high throughput and minimal investment. But increasingly we're looking at logistics operations which are point to point, which means developing refueling networks interstate, intrastate. And so what we're doing is working with hydrogen producers, hydrogen infrastructure suppliers, oil companies around how do we site these stations across Australia, in what kind of hydrogen do we produce. Obviously our preference is for low carbon hydrogen, and exactly what are the best models to achieve this. So we are looking at the Hydrogen Hub model as being really the best way to go forward, which really concentrates producers and users of hydrogen and allows us to scale up both infrastructure and vehicles very, very quickly. And so we're working with a number of the port operators across Australia as an example, which are really fast tracking their development towards hydrogen export and wanting to dabble in vehicles as a starting point. Next slide. So Hyzon is scaling up its presence in Australia. We currently have a team of about 20. Our headquarters are in Melbourne. We're really keen to talk to fleet operators around their transition to zero emission vehicles. I think the most important point is this technology is available today and is being deployed into Australia. So it really is about how do we familiarise operators with hydrogen technology, address any concerns around the feasibility, and really show that these vehicles can be a one-for-one replacement with diesel and will be the future of commercial mobility going forward. So thank you.
Thank you very much, Claire, for that fantastic and fascinating presentation. Really exciting journey for Hyzon, and I'm sure we share sentiments that we're very much looking forward to seeing those hydrogen vehicles in Australian roads in 2022. We now come to the panel discussion session of our webinar, and I would like to welcome the moderator of the panel session, Professor Sally MacArthur. Professor Sally MacArthur is Director of Swinburne's Manufacturing Futures Research Institute, and she's also co-director of MedTech Vic. Her personal research couples materials, surface engineering, physical science, analytical chemistry, and biochemistry. She has obtained approximately $22 million in funding from research councils, industry, and governments in the UK and Australia. Please welcome Professor MacArthur.
Thanks so much, Gordon. It's great to be here today. I wanted to also say thank you to so many great presenters today, and it's really initiated some really interesting questions online, which I'm excited to see, and really keen to see that they actually combine really nicely into the questions that we were already thinking of seeding this with. But before we get going, I'd like to introduce you to welcome Dr. Stephen Percy to the panel and to our whole panel's discussion. Steve's a senior research fellow at Swinburne University in our VH2 initiative. His research and advisory works on applying electrical engineering modelling, optimisation and data analysis to understand hydrogen supply chains. Steve was a Churchill Fellow in 2020 and has 10 years experience working across the energy research domain. So it's great to have Steve with us today. So if I can bring everybody into the panel discussion today, and I'm going to ask, I'm going to link back in, hopefully, to some of these questions. But first I'm going to start with you, Claire, because that was such a beautiful display of where the opportunities are. But a question that's coming out from a number of people is hydrogen. Just how safe is it, and how are we going to make it work within this large-scale transport system? Have we got enough engineering standards there? What have we got to do yet to get there?
It's a great question, and one that often comes up. And hydrogen is a flammable gas. It needs to be handled with care, as per any fuel. The fortunate thing is that while we're talking about hydrogen in mobility today, hydrogen in industry is a decades and decades long sector. So we have an enormous amount of experience in producing hydrogen, handling hydrogen, storing it and distributing it. In terms of hydrogen on vehicles, hydrogen tanks are thoroughly tested. There's obviously standards in place for gaseous hydrogen storage. There's also standards in place for electrical systems on these vehicles as well. In terms of the mass storage of hydrogen, we play in the commercial mobility space. We're talking about larger vehicles. It presents us with an opportunity to store more hydrogen on a large vehicle versus a light vehicle, as an example. So what we do is we work with the operator to understand their range requirements, how much hydrogen they require on board. And then we have a storage system where we essentially store the tanks behind the cab and also on the side rails of our vehicles. And these tanks are pressure tested, they're gunshot tested, they're dropped from high heights. Essentially, they do everything to these tanks. The fortunate thing about hydrogen is if there is a leak from the tank, it's 14 times lighter than air. So typically it will just dissipate. So anyone new to hydrogen can be assured that the standards are in place. Australia is adopting these standards at the moment, and it's tried and tested technology.
That's fantastic, Claire, because I think this is a really interesting space where people's expectations of what can go wrong are possibly out of whack with where we're at in actually thinking about and how much hydrogen we just use every day anyway. So that's really cool to know. So Hussein, you work across all the ranges of transport opportunities and all the types of energy that we can use. And a number of people have asked questions about, okay, should I be thinking about how do I compare electric vehicles to hydrogen-powered vehicles? And what are the choices? You know, we've already got electric cars that we're pushing to get into the market. Do we really need to add hydrogen into a domestic car market? So perhaps you want to comment on that balance across the marketplace.
That's an excellent question as well. And as Claire mentioned, one of the key advantages for hydrogen is range and fast refueling. So that is a key criteria. So as you saw in some of my slides, the longer the range, hydrogen would have more opportunities. And especially if you look at shipping and aviation, it's not very easy to park somewhere and charge the batteries, for example. So this is where larger opportunities will come into place. In terms of electric versus hydrogen vehicles or passenger cars, possibly they're the same weight, maybe 1.8 ton, 1,800 kilograms. Clearly, the hydrogen vehicle would have more range, more mileage. In terms of, I was looking the other day at the Tesla versus the Mirai. The Tesla, the acceleration 0 to 6 is 4.2 seconds. The Mirai probably around the 9. Refueling time, if you have electric vehicle, it could be 20 minutes to 40 minutes, depends on the type of charger. With the hydrogen vehicle, it can be very fast, a few minutes. Another key consideration, especially when it comes to renewable, is that the amount of energy needed, for example, to have a hydrogen vehicle travel 1 kilometer, the same amount of energy can be used to have an electric vehicle drive 3 kilometers. So the issue of efficiency is another consideration.
Excellent. That's really useful. Thank you. Patrick Hartley, infrastructure. How are we going to deal with it? That's the big thing. I mean, Claire did a really nice explanation of it's easy if everything's coming back to the same point, but not everything does come back to the same point, and we have huge distances in Australia. So how are we going to address this infrastructure question? Is that going to be a rate limiting step?
I think it certainly is, and certainly has been. I mean, I mentioned in my the roadmap graph that I showed from 2018. Mobility is a low-hanging fruit for hydrogen, but it's taken a while to get going, and that absolutely is because of the lack of infrastructure. It's in many ways it's actually the gas networks industry that has driven the hydrogen demand for the this early phase, which is because they've got the infrastructure in place. They've got their pipelines that they can actually put hydrogen into. So the infrastructure rollout is key. Projects like ours, where we're taking a certain approach to installing infrastructure on our side. So you're going to see much more of that. And I think, as Claire mentioned, we're probably going to start with these back-to-base models, where a single piece of refueling infrastructure can power a fleet of back-to-base vehicles. I think we'll see partnerships as well. I think one of the other things about the infrastructure is it's not cheap, and consequently partnerships where multiple companies might work together to establish a piece of infrastructure and then use that infrastructure in different applications in different industries will be important. And then as we move beyond those back-to-base models, you'll start to see refueling networks. They may well end up being corridors along major arterial roads, particularly for that heavy transport opportunity, which is where hydrogen really comes into its own. And then gradually you'll see these networks expand beyond back to the way I would see it, back to base, corridors, and then expansion of networks. It will be the trajectory, but it is going to take time. That infrastructure is not cheap, and from the vehicle perspective as well, there's not really a huge number of hydrogen vehicles around in the heavy sector that Claire was talking about. That's just getting going.
Excellent. Thanks, Patrick. Steve, welcoming you to the panel, and I know you've done a lot of modelling around a whole range of different areas, and there's been a couple of questions that have just come up in terms of that balance of how we generate the hydrogen to start with. Are we using just coal-based electricity to generate? What's the value in that? But also the other environmental questions around water usage. Maybe you could just comment on those two sides of things. What's the modelling telling us, and how should we be thinking about this?
Yeah, so thanks for allowing me to join the panel. And these are really good questions and things that we really need to start thinking about now. So there's a few ways to produce hydrogen. Obviously, there's, as you mentioned, coal gasification. This requires the capture of the carbon from that gasification process and that to be stored somewhere. So they're looking at potentially storing this in the Bass Strait. But this, you still have emissions from producing blue hydrogen. About 10% emissions come from that. Another way is producing it from electrolysis and using renewables. And we've been doing some analysis evaluating the price that hydrogen can be produced at, and using using wind and solar as the energy source, and co-locating an electrolyzer. So this sort of production on the water point, so it uses about 10 liters of water to produce 1 kilogram of hydrogen. And just for example, filling up a bus would use about 50 liters of hydrogen, or 50 kilograms of hydrogen. and hence would use about 500 litres of water. So it is something to consider, and this might actually lead into where we end up producing the hydrogen in the future. There is work looking at using seawater in the electrolysis process instead of having to use fresh water, but this is something still in development, but that's an option for the future.
Yeah, it's really important, I think, to be thinking about all of the steps in this cycle, isn't it? Because we recognize that if you don't have the water around, you are going to have a challenge with how much hydrogen you're going to be able to make as well. But super exciting, some of the materials advantages, I think, that are coming through as well. So on this same sort of point, Sean, really exciting to see the scale of the units that you're starting to see. I love that Boston shot of it just tucked in next to and using the solar coming off the roof and the wind. How are people feeling about storing that hydrogen and that efficiency of the loading and the pressure levels? Maybe you can tell us a bit about that and where that's heading at the moment and how you're thinking about it.
Yeah, thanks, Sally. I think you've hit on a really good point, which is about the change that goes from a liquid fuel to a gaseous fuel. We've been dealing with gases and refueling for CNG and renewable gas and now hydrogen for decades, so we're very comfortable with it. But in reality, for the community at large, they need to feel safe, be safe, and get a great experience. So in terms of the question you asked, is it evolving? There's global standards, as Claire espoused too. I mean, hydrogen's not that new. It's new to be commercial, on the commercial pathway. But a lot of the standards that are being developed have been around for a long time. They're now being updated. There's specific refueling couplings to enable fast filling in a very safe environment. What I would say is gas. There's a couple of thousand, or there has been thousands of CNG buses operating around Australia at not dissimilar pressures to what we're talking about, 250 bar type pressures. Hydrogen for trucks is around 350 bar. So those buses have been operated for many decades in Canberra, Sydney, Brisbane, Adelaide, and Perth. So people don't talk about or think about it, but actually it's not as big a step as we think to go to a gaseous platform. They're very safe, very reliable. We've been working with Hexagon Purus, which is a vessel manufacturer. It really is global platform stuff. And all I'd say is I'd literally rather be near a hydrogen vehicle than a petrol or diesel vehicle in the event of a fire or explosion. They're very safe, risk assessed, and market ready.
Excellent. Thank you so much, Sean. Steve, actually, I wanted to come back with you for one more thing, because we've had quite a few questions around how do we predict and model how this is going to work. And I know that this is an area that you're looking at. So maybe you could tell us a bit more about what types of things you're modeling and the types of approaches you're taking to try and get to some of these questions without us having to build it and test it.
Yeah, good question. So one piece of modeling that we're working on now is evaluating the cost of the levelized cost of producing green hydrogen at every renewable energy zone. And that sort of modeling, and we're doing this out till about 2050. The model actually allows us to evaluate the levelized cost of hydrogen produced using an optimal mix of wind and solar. And this feeding into this is cost forecasting. The sort of costs are the cost of building new wind and solar generation, the cost of the electrolyzer, and maintenance. In that, as well as the renewable potential at every renewable energy zone in Australia. And so we can bring this all together and provide a forecast of hydrogen price in the future. And we're finding that in the short term, while electrolyzers are quite expensive, we end up having a lowest cost hydrogen production actually occurring in South Australia and Queensland. But this actually shifts in the future when solar prices are expected to fall quicker, and also electrolyzer prices are meant to fall considerably. And we find in the future, so 2030 to 2040, the lowest cost hydrogen sort of is coming from very sunny areas, so Queensland, inland South Australia, inland Victoria, and New South Wales. And that brings in new challenges around moving the hydrogen to demand centers, and that requires even more research. But this is the sort of thing, and naturally with this, we're considering a range of forecasting scenarios and how those prices might change in the future. And what that sort of indicates is that we might actually end up with cheaper hydrogen quicker if electrolyzers become a lot cheaper. But this is all something we're learning and trying to understand and allow for that sort of planning to allow us to produce hydrogen at the lowest price possible. Yep.
That's fantastic, Steve. Thanks for that. And I think it raises that really interesting question of some of those, like Tasmania, only makes green energy anyway. So their base load in Tasmania is pretty much driven by green. So there are other places that you can start to explore some of these things, I think, as well. We've got time for one more question. I'm going to ask it to Claire, because as the director of the Manufacturing Futures Research Institute at Swinburne, I'm super excited about how we get beyond just buying in the trucks to making things in Australia, and where you're seeing the opportunities, and what are the things that need to really make a difference to make sure that we do start making these trucks and these buses and other things that we can for the hydrogen sector in Australia.
Oh, absolutely, Sally. As a previous employee in a manufacturer that was building cars in Australia, I think one of my greatest passions is resurrecting local manufacturing of vehicles here in our country. And I think hydrogen does present an opportunity to do that. In fact, Hyzon is looking at this very opportunity. So we see that there are some really bespoke applications for our market. One in particular, which I'll talk about, is rubbish trucks. So we're talking to councils nationwide, also waste management companies as well, about their need to transition. A small number have trialled battery electric rubbish trucks. They're not stacking up from a power draw perspective. Significant torque. These vehicles, high utilisation vehicles, and we believe that hydrogen is the best technology for that. Australia has some unique specifications for those vehicles, so we see an opportunity to start building them here in Australia. And similarly with the road trains, which I touched on before, with companies such as Arc Energy. So I have no doubt that this will open up the avenue for companies such as Hyzon and others in this space to start investing in local facilities and start building vehicles, and hopefully get that supply chain up and running again as it once was in Australia. So I think that opportunity is absolutely emerging.
Fantastic. That's such an exciting thought, I think, to really think about all of those parts of the supply chain that we can reinvigorate through hydrogen and the production of products and services that will actually make a difference to our carbon future, but also make a difference to our employment opportunities and things in Australia. And VH2, I know, is super keen to be part of all of those conversations. And so I'll take you back to Gordon to close off today, and thank everybody for all your contributions.
My apologies, I was on mute there, but thank you very much, Sally, for facilitating the panel discussion. Just looking at the level of questions, I think we could have continued this discussion for another hour, but unfortunately, we run out of time for today. So please join me again in thanking our speakers today, Professor Hussein Dia, Dr. Patrick Hartley, Sean Blythe, Claire Johnson, Dr. Stephen Percy, and of course, Sally MacArthur for facilitating the panel session. I would also like to thank Engineers Australia for partnering with us for this event and making this webinar possible. So we'd appreciate your feedback for the program today to help us improve future events. And just looking at the level of interest for today's webinar, we'll certainly look at developing similar programs and similar webinars and events around some of the work we're doing in VH2. We're always keen to talk to industry partners. So if you have an interest in talking to us and some of the work we're doing, you heard from Dr. Stephen Percy about the work he's doing on the modeling work, please contact us either through Engineers Australia or our website is up and running. You can contact us through the contact details on our website. So thanks again for joining us, and we hope to see you at our next webinar. Thank you.